Have you ever wondered how an engineer knows a concrete column will be able to adequately support a building? Well, it's actually a fairly simple equation which comes from the ACI building code, which I'll be showing you guys today. Before we get into the equation, we have to actually understand what's in a concrete column. So this is a concrete column before the concrete is actually poured, and you can see these longitudinal rebars running up and down. These add axial capacity to the concrete column, and then these transverse reinforcement, they're called ties. They help confine this longitudinal rebar and make sure that it doesn't buckle, and they almost act as a sort of bracing for the longitudinal rebar. So now jumping into the ACI code, we can see this equation here, and it's actually fairly simple because all it is the left side of the equation is taking the gross area of concrete and multiplying it by the concrete's compressive strength, and then this right side of the equation is taking the gross area of steel and multiplying by the steel strength. So after you've plugged and chugged through this equation, you can go up into this table and multiply by the next factor, which is based off of your transverse reinforcement. Most columns use ties, so that'll be 0.8, and once you multiply that factor, you'll have your nominal axial capacity. So for structural design, we also have these strength reduction factors from this table, which lowers the capacity of the member you're designing, but they're there to account for any uncertainties in design or construction. So for a tied column, we'll be using that strength reduction factor of 0.65, which means that if you have a design load of, let's say, 1,000 pounds on your column, you'll need a nominal capacity of about 1,550 pounds for your concrete column, so that after you apply that strength reduction factor of 0.65, you'll still be above your design load of 1,000 pounds. So I hope you learned something and got a little bit of insight onto how we actually design these things. And if you have any more questions or want me to run through a practice problem, just let me know.